So the first thing we need to do is we need to convert the system into a matrix. And to do that, we're going to use something called slack variables. Slack variables convert inequalities to equalities by taking up the slack in the inequality. So let me show you a sample. So here we have one of our constraints, and what this is showing is that the left-hand side is less than or equal to 118. Now at this point, this is not an equality. So what we're going to do is, because we know the left-hand side is smaller than 118, we're going to add a little bit to that left-hand side. In fact, the amount that we're going to add is S1. Now, I don't know what S1 is right now, but since everything's positive here, I know that if I add a little bit to the left-hand side, and it's just the right amount, that's going to make it equal to 118 instead of less than or equal to 118. So let's look at the other constraint. 4x1 plus 5x2 plus 10x3 is less than or equal to 220. And I need to add just enough to the left-hand side so that I end up with these being equal. So I'm going to add a slack variable, S2, which is positive, and I'm going to add just enough, so instead of the left-hand side being less than or equal to 220, it's going to be equal to 220. So now with that in place, let's go back and take a look at our original linear programming problem. We have equalities here with our two slack variables, but nothing else has changed. All we did here is we converted the inequalities to being equalities by the addition of the slack variables. Now let's take a look at the objective function. We're going to go ahead and rewrite that objective function in a slightly different manner. We're going to take everything that was on the right-hand side here and move it over to the left-hand side. So instead of z equals 8x sub 1 plus 3x sub 2 plus x sub 3, if we move the x sub 1, x sub 2, and x sub 3 terms to the other side, we end up with minus 8x sub 1, subtract 3x sub 2, subtract x sub 3, plus z equals 0. So now what we basically have done is the objective function and the two constraints are all written as equalities with the variables all on the left-hand side and the constants on the right-hand side, and now this is just right to be put into an augmented matrix. So that's what I've done down here below. I've taken that 7x sub 1 plus 6x sub 2 plus 8x sub 3 plus s1 equals 118, and I've gone ahead and put it into the first row of my augmented matrix as 7, 6, 8, 1, 0, 0, 118. Notice how I've listed out all my variables up above here so I can keep track of which coefficients went with which variables. The two zeros in the last two places are there because that first equation did not have an s sub 2 or a z in it. My second constraint, 4x sub 1 plus 5x sub 2 plus 10x sub 3 plus s2 equals 220, when I put that into my augmented matrix, it becomes 4, 5, 10, 0, 1, 0, 220. My objective function, which was minus 8x sub 1 minus 3x sub 2 minus x sub 3 plus z equals 0, it goes in the bottom row as minus 8, minus 3, minus 1, 0, 0, 1, 0. The vertical bar corresponds to the equals in my system, and this horizontal bar here simply separates my constraints from my objective function. So here we have that matrix, and I've highlighted for you where the constraints are up in the top part. The objective function corresponds to the last row, and now something new, which is the indicators. The indicators are the numbers that correspond to all the variables in the objective function, excluding the 1 that corresponded to the z. The fact that I have negative numbers here is going to be very important to us later on. This matrix is called a simplex tableau, and it's the starting point of the simplex method of solving a linear programming problem. Often you'll see this called the initial simplex tableau, or just the initial tableau, because this is the first one we run into when we're converting from the linear programming problem that we started out to the matrix form we have right here. So let's go ahead and take a new problem and let's rewrite that in the initial simplex tableau. So what we have is maximize z equals 10x1 plus 12x sub 2, subject to the constraints 2 times x sub 1 plus 3 times x sub 2 less than or equal to 11, 5x sub 1 plus 2x sub 2 less than or equal to 20, x sub 1 plus x sub 2 less than or equal to 4, and our non-negativity constraints, x sub 1 is greater than or equal to 0, and x sub 2 is greater than or equal to 0. This one's a little bit different. We still have that we're maximizing, but this one just has 2 variables in it. We have 3 constraints this time, which makes it a little bit different, but they're all less than or equal to a non-negative number. So we know this has the proper form, and we have the non-negativity constraints. So we'll need to rewrite the constraints with slack variables. We'll need to modify the objective function, and then put it into the augmented matrix. First thing we're going to do is take my 3 constraints, and we're going to add slack variables to each one of them. Notice over here that we've added a different slack variable for each one. For instance, on the last constraint, which was x sub 1 plus x sub 2 less than or equal to 4, that's x sub 1 plus x sub 2 plus s sub 3 equals 4. And I've done the same thing for my other constraints. So I have my objective function, z equals 10x sub 1 plus 12x sub 2. If I modify that by putting all the terms on the left-hand side, I get minus 10x sub 1, subtract 12x sub 2, plus z equals 0. So that gives me the equalities that I needed, and now I just need to take those equations and put them into an augmented matrix. Here I have a 4 by 7 augmented matrix. I have column labels here of x sub 1, x sub 2, s sub 1, s sub 2, s sub 3, and z. Notice how I always put the original variables first, then I put the slack variables. I don't have to set it up that way, but that's the way your textbooks does it, so we're going to keep with that. So my first equation that comes from a constraint was 2x sub 1 plus 3x sub 2 plus s sub 1 equals 11. So when I put that into the first row of my matrix, I get 2, 3, 1, 0, 0, 0, 11. I do the same thing with the other 2 constraints, and you see those rows down here. And then under the horizontal bar, I go ahead and take my objective function, which is minus 10 x sub 1, subtract 12 x sub 2 plus z equals 0, and I write that in the bottom row as minus 10, minus 12, 0, 0, 0, 1, 0. So now this is my initial simplex tableau. Now what I need to do is I need to start modifying this or looking at a possible basic feasible solution based on this tableau.